In a previous session, when we were trying to figure out that gamma of 1 by 2 is equal to root pi, we had encountered a double integral. There I didn't really get into the details of it. So let's do that now. Because again, we are going to be using it. Given two curves, f of x and g of y. So let's say f of x is this and g of y is this. We are interested in the product of the areas under these curves from 0 to a for f and 0 to b for g. Area under the function f is equal to the integral from x equal to 0 to x equal to a of f of x dx. And similarly, area under the curve g is equal to the integral from y is equal to 0 to y is equal to b of g of y dy. The first step is we draw a flat rectangular region in the xy plane. The rectangle will be a by b. Okay, so let's draw that rectangle. This area we are going to treat it as the domain. Now area under f within this interval maps to the height in the z direction along the x-axis edge. Now this is the area under the curve f of x. Now you might have noticed that that curve is on the xy plane and this is in the xz plane. Basically what I have done is graph the area under the curve in the xy plane in the xz plane. So if you want to compare it, let me draw that curve also in the xz plane. So it is going along that curve. So this is the area under f. Now area under g in the interval 0 to b maps to height in the z direction along the y-axis. So this is the area under this curve in the interval 0 to b. Now the height at each point x comma y in that domain is the product of two 1D heights. Now let's complete this figure. So what we are going to do is draw the remaining walls and we are going to draw the roof over the rectangle. So here the volume under the roof is a product of two areas under two curves f and g. So volume of the solid is equal to area under f times area under g is equal to the integral from x equal to 0 to x equal to a of f of x dx times the integral from y is equal to 0 to y is equal to b of g of y dy. The roof is three-dimensional surface. So z is equal to h of x comma y, which is equal to f of x times g of y. So volume is equal to the double integral over the rectangle of f of x, g of y, dy, dx. In this particular case, we can say v is equal to the integral 0 to a, integral 0 to b of f of x times g of y dy dx. Let's take care of the inner integral, that is with respect to y. So in that case, f of x is a constant, so it comes out and we have f of x times the integral from 0 to b of g of y dy, which is equal to f of x times this integral is nothing but a sub g, area under the curve g. We substitute this back into v. So v is equal to the integral from 0 to a of f of x times a sub g dx. Again, now that we have the area under g, that's a constant now, so it comes out. and we have v is equal to a sub g times the integral 0 to a of f of x dx, which means v is equal to a sub g times, this is nothing but area under f, so a sub f. So what have we shown? We have shown that a double integral of a product of two functions in two variables is equal to the product of two integrals. That means the double integral can be split into two separate integrals and multiplied together, which is what we had used when we were trying to figure out gamma of 1 by 2 is equal to root pi. So to summarize it, remember this is Fubini-Tonelli theorem. So conditions for Tonelli theorem, the integrand is non-negative in the interval, which in our case for gamma of 1 by 2 is equal to root pi. In that case, they both were non-negative. Conditions for Fubini theorem, the integrand can be positive or negative, but we need to check for absolute integrability. So that means double integral, absolute value of h of x comma y should be less than infinity. What does this let us do? It lets us change the order in which we integrate. That means we can swap the integrals. We can, here we are, the inner integral is with respect to y and outer one is with respect to x. We can actually change the order. We can take the inner integral as with respect to x and outer integral with respect to y. Integrals can be broken up and integrals can be combined. So we can go forward in this direction or we can go backwards in this direction. So that was Fubini-Tonelli theorem.